Our next topic, we will going to discuss about one-way slab. So kapag sinabi nating one-way slab, yung nangyayari is let's consider a certain portion of our slab. So meron tayong shorter span which is denoted by capital S, and we have a longer span which is denoted by capital L. So kapag one-way slab yung nangyayari is so meron tayong load na naka-apply dun sa slab natin. So yung tendency nun is yung load natin that was applied on our slab, it will be distributed along the longer span. So mangyayari, so hahatiin ngayon, maghahati ngayon yung longer span. Etong kabila is mapupunta dun sa other end ng longer span natin, and yung remaining naman, it will be loaded along the longer span. So, para masabi natin na one way yung slab natin, so kung kukunin natin yung ratio ng shorter span to the longer span, dapat that must be less than to the value ng 0.5. If that is less than yung ratio ng shorter span to the longer span, therefore, one-way slab tayo. So if that is less than, if that is greater than or equal, two-way slab naman yun. But for now, let us discuss first yung one-way slab natin. So let's say, eto yung ano natin, slab natin. So we have a slab here. So this is our shorter span, and this is our longer span. So in one-way slab, nangyayari is yung bending natin, it is occurring on our shorter span. So if we have a bending on the shorter span, so para malabanan natin yung bending, we will put reinforcement. So maglalagay tayo ng reinforcement along the shorter span to resist the bending effect. So maglalagay tayo ng bakal on the shorter span natin. So etong tawag natin sa mga bakals natin, which is yung mga main bars na tinatawag natin. So, sa one-way slab natin, nangyayari is yung mga main bars natin. So, which is tinatawag natin mga bottom bars. So, it resist yung bending para malabanan niya yung bending on the shorter span. So, yung mga main bars natin, usually, that is on the bottom part ng mga slabs natin. Tapos, sa taas, so let's say this is our main bars. So, sa taas niya is yung mga tinatawag natin mga temperature bars na nakahilera. Okay? So, for this, yung main na dinidesign natin is the bottom bars o yung mga main bars natin. Again, to resist yung bending effect natin on the shorter span, we are putting reinforcement natin dun sa shorter span para to resist the bending effect. So, usually ginagawa natin in computing considering one-way slab natin, we are considering a 1 meter strip. Dito niyan magko-consider tayo ng 1 meter strip. So with this, kukuha tayo dito ng 1 meter strip. So this is 1 meter strip. So upon considering 1 meter strip, masolve na natin yung other criteria nung one-way slab natin. And with that, so para malaman naman natin yung thickness nung slab natin, kung gaano siya kakapal, so meron tayo ditong mga minimum values. So kapag simply supported daw, that is denoted by, so pagkanting simply supported natin, okay, so yung minimum thickness daw natin, that is L over 20. So kung ayusin natin yan, so let's say ayusin natin yung figure natin, so gawin natin siya sa mga plants, let's say ganito yung natin. Ayan. So this is a simply supported beam. Kapag naman one end continuous naman, so let's say eto naman, meron tayo dito. Ayan. Tapos meron tayong ayan. So meron tayo ditong continuous end, 'di ba? Sa isang end natin, continuous siya or meron siyang katuloy. So that is L over 24. Paano naman kapag both end continuous? So let's say meron tayo dito na beam. At tapos dito, ayan. So meron daw siyang katuloy dito na span. Dito din sa kabila, denoted by etong letter, etong ano na to. Ibig sabihin nito meron siyang katuloy. Okay. So that will be denoted by L over 28 kapag naman cantilever. So pag ganito lang tayo kapag cantilever. Ayan. So that is L over 10. So that will be yung minimum thickness natin na gagamitin natin later sa pag-solve ng minimum thickness ng slab natin in computing for the reinforcement. So mamaya gagamitin natin yung mga yan. And of course, using meron tayong mga ACI code limitations. Yung minimum thickness ng slab natin, that is only 100 mm. Yung minimum concrete cover, that will be 20 mm. Yung minimum structural covering, that will be 25 mm. And of course, yung minimum diameter of your main bars, that will be 12 mm. And yung temperature bars naman natin, that will be 10 mm. So, ito yung shorter span natin. So, ito yung shorter span natin. And nandirito naman, nakalatag yung mga temperature bars natin. So, ito yung mga typical design steps natin in computing for one-way slab. So, una is kunin mo muna natin yung dito, uniform floor pressure. That is in terms of kPa. So, it usually involves yung mga dead load natin na ikakarga dun sa structure natin. So, we have the given dead load at saka yung live load natin dyan. So, gagamitin natin yung mga formulas natin para maging ultimate yung mga service loads natin. And then, kunin natin yung thickness ng slab natin. That is yung age minimum natin. So, usually, since minimum yan, so kapag natin, usually yung mga slabs natin dyan, yung mga thickness, always round up yan to the nearest tens. So, basta't yung mga values natin, hindi dapat siya bababa dun sa age minimum. And after natin makompute yung age minimum, siyempre, meron na tayong given na thickness ng slab natin, we can now calculate for the value ng weight of slab natin. Kasi meron na tayong value ng thickness niya. So, ilalagay na natin ngayon, kukunin na ngayon natin yan. So, yung uniform pressure load natin na naka-kPa. So, yung weight ng slab pala natin. Ayan. So, yung weight ng slab natin, di ba, meron tayong unit weight of your concrete multiplied by yung thickness natin or yung age minimum natin. So, that would be your weight of the slab. And after nating makompute yung weight ng slab natin, we're going to compute yung maximum moment natin na kasama etong weight ng slab natin. And after nating makompute yan, mangyayari nyan is yung MU max natin, equate natin yan to the M capacity. So, yung nakuha natin sa number 4, i-equate natin yan to the formula natin for M capacity para makuha natin yung value ng steel ratio natin. So, with that, yung formula natin, kung matatandaan natin, ititit lang natin to katulad lang ng ng parang one way, katulad ng beam. Okay? So, ito yung mga formulas natin sa singly reinforced beam. So, for this one, we have the reduction factor multiplied by the nominal resistance, multiplied by the width of the width, and multiplied by the effective depth. So, kung i-decongest natin yung R sub n natin, ito yung magiging formula niya. Rho Fy multiplied by 1 minus rho Fy over 1.7 F prime C. So, using this formula, makukuha na natin yung rho. Kapag nakuha natin yung actual C ratio, we can now check for the ductility. So, ipagko-compare ngayon natin yung value ng actual natin to the value ng maximum rho and the value of your minimum rho. So, kapag nag-less than, kapag nakapagitna yung value ng actual rho natin to the value ng rho minimum at saka rho max, meaning to say, ductile failure tayo. Or let's say, dito naman nangyari is your rho is greater than daw siya dun sa value ng rho maximum natin. So, yung gagawin natin dyan to resolve that is we will going to increase the depth of your slab. Kasi, hindi kakayanin ng slab natin yan. So, kailangan, yung tendency dito dapat yung raw max natin, dapat yan yung pinakamataas kapag nasa slab tayo. And kapag naman yung raw natin, that is less than to the value ng raw minimum natin, so gawin natin is yung raw natin, equate natin siya to the value of your raw minimum. After that, after we check for the ductility, we will going to save for the spacing of your main bars. So let's say again, this is your shorter span. So eto na ngayon yung mga bakal natin or yung mga main bars natin that will resist the bending effect. So eto yung mga i-compute natin na spacing. So for this one, meron kang given na value ng rho natin. So gagamitin natin yung value ng rho to compute for the value of your total area of your steel. So remember, nangyari, di ba, meron tayo dito, we consider a 1 meter strip here. So, ang gagawin natin yan in terms of millimeter, that will be 1,000 millimeter. So, meaning to say, yung total area daw ng mga bakal natin na nakahilera at nadirito sa sa strip natin, so that will become i-ratio proportion lang natin, AS over yung strip natin na 1,000 equals yung area ng isang bakal over yung spacing na hinahanap natin. And after that, gagamitin natin yung mga actual values na nakuha natin. I-check natin yung flexure at saka yung shear. And lastly, we're going to solve for the value of your spacing of your temperature bars. So for the spacing of your main diameters or yung mga main bars natin, so meron pala tayong value ng maximum spacing natin. So that will be 3H nor 450 mm. So itatrace lang natin yung nakuha nating thickness ng slab natin and i-compare din natin yan to the 450 mm. So after natin ma-compute yung spacing ng main diameter bars natin, we're going to compute for the value of the spacing of your temperature bars. So kapag temperature bars naman, in computing for the value ng area, ng total area ng temperature bars natin, we're going to refer kung ano yung given natin na Fy. If your Fy is within the range of 275 megapascal to 345 megapascal, your AST will equal to 0.002 BH. So yung B natin, that will be yung 1 meter strip natin, which is equal to 1,000 mm. And yung H natin, that will be the thickness of your slab. So for this one, meron na tayong given na mga formulas in computing for your temperature bars. Kaya mas madali siya compared in computing for the value of your main bars. Kasi sa main bars, ang dami nating procedures na pagdadaanan bago natin siya makuha. And if your Fy is within the range of 400 to 415, this will be the value of your AST. And we have a value of our AST minimum, which is equal to 0.014 pH. Kapag naman nag-exceed yung value ng Fy natin to the value ng 415 megapascal, so, gagawin natin is, imumultiply lang natin yung 0.0018 pH natin by 415 over Fy. And para makuha natin yung spacing, gagamit lang tayo ng ratio and proportion. Yung total area ng bakal na merong 1,000 mm is equals to yung area ng isang bakal over yung spacing. And then, chip solve lang. Makukuha natin yung spacing and i-compare natin yan to the value ng S-max natin, which is equal to 5H or i-multiply natin by 5 yung thickness ng slab natin, nor 450 mm. And after, balikan lang natin yung minimum thickness natin. So this will be your minimum thickness, 4 simply supported, 1 end continuous, both ends continuous, at saka cantilever. So etong mga to, applicable lang to kapag 420 yung Fy natin. 420 megapascal. For Fy other than 420, gagawin natin itong formula natin na to, imumultiply lang natin ng 0.4 plus Fy over 400. So let's say yung Fy natin that is 415 megapascal. So gagawin natin yan is L, tapos simply supported L over 20 over 0.4 plus 415 over 700. So this will be the formula in computing for the value of your age minimum. So let's have a sample problem para lalo yung ma-visualize yung design steps natin sa pagde-design ng one-way slab.